we finish this pin diagram, this pin diagram has a lot of complication in this side, on the right side. Fine. So what we have, the new thing in the right side of the 8086 pin diagram is its operational capability. Fine. So if we talk about 8086, there are two modes of operation. Modes of operation of 8086, there are two modes of operation. It can work in two modes. Fine. It is, first one is called minimum mode and the second one is called maximum mode. All right. So before we complete the pin diagram, that thing we have to understand first, that what is the minimum mode and what is the maximum mode. Fine. So what we know about is, in order to tell you about the 8086, that it is coming from the previous designed structure of 8085. It's like it moved from 8085 to 8086. All right. So just think of something, that 8086 is also down compatible. That means it is somehow compatible to 8085 also. Fine. So just imagine 8085 is enhanced. 8085 is having 8-bit capability. Now 8086 is having 16-bit. 8085 was having 16-bit address bus. Now it is having 20-bit with modified architecture. So altogether 86 is different. But if somehow I want 8086 to work in the minimum mode, that means the minimum operations it can do just like 8085, a downgraded processor. Fine, although it will be having the extended capability like 16-bit data bus and 20-bit address bus. Fine, but here if we are selecting the minimum mode, it will not be function not it will not be fully functional. It will be working like a downgraded processor. It will not use its full capacity, because 8086, the moment you will be shifting towards the I'll be telling you the actual operation of 8086, you will be amazed that it can do a lot of things. It is very well and carefully, meticulously designed. Fine, but still, if you want that to be working in a minimum configuration, that is also possible. But if we want that 86, the actual operation of 86 should be selected, then we have to select it in the maximum mode. Then the actual operation of 8086, either it is multiprocessor communication, or it is segmentation, or it is somehow related to pipelining, or multitask, something like multitasking, or you can say a lot of things, parallel processing, lots of stuff. Fine. So this is where the maximum utilization of 86 capabilities will take place. But here only the minimum capability, minimum downgraded functions of 8086, just like an old 8085 processor. If it is you want that to be work like that, you can select in minimum, but in maximum, the full-fledged operation will take place. Fine. So in order to select minimum mode as well as maximum mode, just look at the pin number 33. This is the most important pin of 8086 microprocessor. This is from where you will select minimum mode and maximum mode, right? So this MN stands for minimum and MX stands for maximum. Fine. So in order to select the actual pin number 33 is like this: MN oblique MX bar. So MX bar, what kind of signal is this? MX bar with the signal with the bar on the top. A signal with a bar on the top. What do we call this type of signal? Anyone, please? We have just discussed in the previous classes. Active low or active high?
Active low.
Good. The signal with the bar on top is called active low. And when it will be active? When,
0.
yes, it will be active when 0 is provided to it as input. Alright, so what happens is the moment we provide 0 to pin number 33, fine, what will be activated? Maximum mode will be activated. At the moment we provide 1 to pin number 33, minimum mode will be selected. Getting my point? So by the single pin, we are doing dual operation. Okay, so let's write it down here. Mn when it is pin number 33 is 1, and maximum when mx bar is equal to 0. This is mode of selection. So whatever you want, just look into the pin diagram. So how should I provide 1 and 0 over here? If I want that pin number 30 through 3 to be selected in minimum mode, how should I connect? How should I make a connection? You can simply connect pin number 33 to VCC. VCC is what? This is plus 5 volt. Fine. And this will give you 1. So if you want to select minimum, you can simply connect it to pin number 40, so that you can have selection of minimum mode. And if you want to connect to the maximum mode, simply connect it to the ground. That will give you the lower state, which is 0. Okay, so this is the way you can select minimum mode or maximum mode, and these are two different operational modes of 8086. Now what differentiation we are having here is, now look into these are different signals in this pin diagram. Fine. So now you need to draw the pin diagram of 8086 very carefully, because now look on to the top of the right side. I've already written minimum mode and maximum mode. Now this thing must be clear to you why these 2 points have already been written. Fine. So the signals which are already connected with the pin VCC, AD, 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 A, BHE, MN, RD bar, hold, HLDA, WR, MIO, DTR, DN, ELE, INT, A bar, test, ready, reset. They are the signals of the minimum mode, right? They are the signals when you select the minimum mode. But what if we select the maximum mode? So what happens in the maximum mode is the signals from VCC to pin number 33, which is selector of minimum maximum, that will remain same. They are common for both minimum and maximum. But after that there will be a change. Pin number 30 also comes into the common part, but starting from pin number 24 to pin number 31, what will be happening if we select the maximum mode? Fine, hold will be replaced by RQGT, HLDA will be replaced by RQGT1, WR bar will be replaced by lock, M oblique IO will be replaced by S2, DTR will be replaced by S1, DEN will be replaced by S0, ALE will be replaced by QS0, INTA will be replaced by QS1. So whatever we are having here, these 1, 2, 3, 4, 5, 6, 7, 8, these 8 signals will take their place inside the architecture, inside the pin diagram, and they will be placed inside the architecture the moment we are selecting the maximum mode. Is this clear?
Yes,
A,
sir.
a swap will take place. The moment you select maximum mode, the signals written under the heading of maximum, they will simply come to this side. Okay, so just be careful while drawing the pin diagram of 8086. It is now getting complicated. Okay, so let's talk about some more signals now. All right, so there is a category of signals which is called control signals or control commands also. They are of two types. RD, RD stands for read, and next one is WR. WR stands for write. These are two control signals. These are two control signals. You will find them in the pin diagram. Read stands for RD bar and WR stands for WR bar. They are for reading something and WR for writing something. They are the control signal. They provide the control what to do. Read karna hai or write karna hai. Fine. So you can simply provide the signal from these what is to be done. If you want to read, read pulse will be generated. If the processor wants to write, the write pulse will be generated automatically. This is pin number 32 and 30, no sorry, 29. Fine. After that, this hold and HLDA. Hold, and along with the hold we have HLDA. They both comes under the category of direct memory access. DMA, it stands for DMA. They are the signals which comes under a different category which deals with DMA. Anyone knows anything about DMA? Anyone? Anyone? Anything you kuch bhi just tell me anything about DMA if you know. The DMA stands for direct memory access. But can anyone tell me exactly what DMA deals with? Anyone, please? Okay, so if this is the case, you guys having no idea about DMA, let me tell you a story. Suppose I take my reference. I am the microprocessor, and you are my objectives or the peripherals I'm dealing with. All of you, all the students. So let's say we are working together. I'm taking my class and I'm delivering in the class. Let's have an analogy. But some of you are thinking that by this speed, the speed by which I'm teaching, I'm delivering my lectures are not sufficient. By this speed, I may not be able to cover the syllabus, and that may be the case because I teach very slow by taking everything in consideration. So you should not skip any logic of basic. So some of you might thought that by this speed you the processor will not be able to complete the job, or I may not be able to finish the syllabus. Fine. So you gave your complaint to your faculty advisor, then you faculty advisor finally submitted to HOD, then to director, and they took a decision in favor of students. So let's do something. So what they did, in order to accelerate the process and to finish the task on time, they replaced me with a new professor. Fine, a new processor. So the replacement is the part of this memory access process. So in place of this old processor, me, some new processor of some active processor will be taking place. Fine. And what it will be doing, the step which is related with hold and HLDA is if my control or the control of my class is going to be delivered to someone else, there is a step of communication. So that communication starts with hold signal. Fine. So somebody, let's think in a logical way. I'm delivering my class. Someone comes from the hold. This is not interrupt signal. It is direct memory access. I'm receiving a signal from hold. Just imagine someone is saying to me, hold your class. Don't teach further. Fine. So if that signal comes to me, I may be surprised that what is happening, why somebody is saying like this, or you can have anyone standing over there, faculty, or it could be anyone. But the signal here is not an interrupt type of signal, it's hold, it's DMA signal. Fine. So operation is like that. When it comes, it has to hold. Our processor has to hold. Fine. So the moment processor is able to hold the process, the processor will send back a signal hold is acknowledged. So what happens in between the hold acknowledges, there is a release of information or release of something. What is that something? What this new processor will be doing, or what it will be requiring in order to operate. Processor requires only three things: the control of buses, data bus, address bus, and the control bus. Fine. So in between, the hold is getting received and processor generates the HLDA signal. In between this very short amount of time, the processor is releasing the control of buses. It is releasing the control of buses from this place to the new processor or the new controller, whatever it could be. So now the new one will be having the control of data bus as well as the address bus as well as the control bus of the previous processor. ठीक है, you just imagine like this: somebody comes to my class, उन्होंने कहा कि आज दिस इज योर लास्ट क्लास, यू विल नॉट टीच फर्दर. आप अपने नोट्स, अपने डिवाइसेस और सारा जो मटेरियल है आप अपनी क्लास में छोड़ के एज इट इज बाहर निकल जाइए. सो आई एम कीपिंग माई बिलोंगिंग्स, माई एड्रेसेस, माई नोट्स, एवरीथिंग ऑन द डायस, एंड आई एम कमिंग बैक एम्प्टी हैंडेडली. This is what we call DMA process. Okay, so what happens after that? The processor comes super fast, and the guy came and he or she completes the syllabus within 1 week. Now you people again in conflict that we didn't want that much fast as a process. That is too fast. Okay, so this is simply an understanding to just to make you understand that this is how DMA works. All right, I at least I gave you a little illogical understanding about DMA. All right, so basically, old and HLD deals with DMA stuff. Next is WR bar, right? We already know it's a control signal for writing. Next we have M oblique IO bar. Fine. So M oblique IO bar along with these status. There will be a table. I don't know whether I'm having this table right now or not. It's not in this slide of mine, although I'll tell you. So M oblique IO, M oblique IO, and someone must be having a bar on top. Which one is having IO bar? So this is for the selection of memory or input output, because what happens is you have any computer system, it deals with, we have already seen the basic diagram of a computer. Inside you have a CPU. CPU interacts with what? The memory, and then input device, and this side it interacts with. This is the basic we have already seen in the CPU part or the block diagram part. So this is what is happening here. Whether processor is dealing with M stands for memory, or it is dealing with the input output, because only one thing can take place at a time. Either it is writing or reading from the memory, or it is reading and writing into the input output devices. There is nothing like no parallel operation. The CPU is also dealing with input and is also dealing with memory. It is also dealing with output. It is also dealing with memory. No, it's not like that. The process is one at a time. Fine. So how memory can be selected, since this is again a dual nature signal by the respected pin. If you provide 1, memory will be selected, and if you provide 0, input output can be selected. So this is whole thing is programmable. You just need to take care of the zeros and ones, and it will be selected and deselected. Fine. So M oblique IO bar is selection of the place where the processor is dealing currently, either it is dealing with the memory or it is dealing with the input output devices. All right, so next we have dt oblique r bar again. dt oblique r bar, and next to dt oblique r bar is den. Fine. So these two signals works together. D stands for, wherever in both the cases, D stands for data, T stands for transmission, R stands for reception. Fine. So DTR is basically data transmission or data reception. In this case, it is low, so transmission can be activated by providing 1 and reception can be activated by providing 0. Next is data enable. Data enable. Fine. So data enable works in closed in conjunction with this dt oblique r bar. Fine. So what we need to transmit, first case, the data should be already available to us so that only we can transmit. So before doing the data transfer, the den should always be 1. The data should always be enabled, then only your dt can be activated. If dn is already 0, this dt will not give you any transmission because there is no enabling of data. So data enabling will actually do what? It will activate or it will enable the data bus for loading the data. Fine. So these two works in conjunction. So next we have is ALE, and this is pin number 25. Guys, try to understand that ALE is the most important operation of a microprocessor, and the similar operation we are having is BHE bar. मैं आपको पहले ही बता देता हूँ, BHE bar and ALE, they both are almost same. They both are almost same. How they are different, and why? If they both are same, then why these two pins are already in pin diagram? Just try to understand. ALE is for minimum mode, and BHE is for the maximum mode. This is the difference, because what's going to happen over here is, now look at pin number 25. The moment 8086 microprocessor is already in minimum mode, then only ALE will be operational. Fine. At that time, BHE will not work. Only S7 will be working at pin number 34. But the moment ALE is replaced by QS0, when maximum mode is selected, pin number 25, then ALE is gone. Fine. So at that time, in the maximum mode, BHE will take place the ALE, and it will operate just like ALE. What was the job of ALE? That will be done by the BHE in the maximum mode. All right. So what is ALE? ALE stands for address latch enable. Fine. Address latch enable. Now, if I ask you something, if you do, all of you are from programming background, so when you start programming, what is the first thing you need? Before even starting the program, what is the first thing you need? Even before starting any computational process, what is the first thing we need? Or is this question really tough?
Audible, sir.
Audible, fine. क्वेश्चन समझ में नहीं आया? ऐसे समझो, प्रोसेसर का बेसिक जॉब है प्रोसेसिंग करना और डेटा को ट्रांसफर करना एक जगह से दूसरी जगह. Fine. So if processor is somehow working like a postman who is transferring the postal orders or postcards or letters from one place to another place, fine. So if a postman has to start the process. पोस्टमैन को अपना काम शुरू करना है, पोस्ट कार्ड डिलीवरी और लेटर डिलीवरी, तो उसको सबसे इंपॉर्टेंट चीज क्या चाहिए? इन ऑर्डर टू स्टार्ट द वर्क, एक पोस्टमैन को अपना काम शुरू करना है, उसके पास एक बैग है, तो व्हाट इट नीड इनसाइड्स द बैग, द लेटर्स और द ईमेल्स और व्हाटएवर इट इज, नॉट ईमेल्स, मेल्स, फाइन। तो उसके ऊपर उसको क्या क्या इन्फॉर्मेशन चाहिए?
एड्रेस।
या एड्रेस,
सर उसका रूट डिफाइन होना चाहिए कि उसे कौन से रूट से चलना है।
वो उसकी एल्गो है, वो उसकी एल्गो है इनिशियली। व्हाट इज द यू से ग्राउंड स्टेट ऑफ दैट थिंकिंग प्रोसेस। अभी एल्गो में नहीं घुसेंगे, एल्गो तब आएगा जब प्रोसेसर के अंदर घुसेंगे, प्रोसेसर काम कैसे करता है। फिर वो पोस्टमैन सोचेगा कि अच्छा मेरे को कहाँ जाना है, कैसे जाना है, कौन से रूट से जाना है, ऑप्टिमाइजेशन कैसे करूँ। That is a different part that we'll study in the next classes. But right now, just think of something. In order to start the process, any process which deals with communication, एक जगह से दूसरी जगह जाना है, this happens with inside the processor. Processor has units. Those units interacts, control unit, ALU, register array, input output units, memory units, and so many other units which are connected as peripherals. So what is happening in those units? The data is traveling from one place to another place, and once it is traveling inside ALU, it will be processed. But again, it will be traveling from one place to another place. So what is the utmost important thing in microprocessor or in a processing system is this: the address should be there. So address of what? Always remember two things in this processor study: source and the destination. They must always be clear that from where this data is coming or from where this information is coming, and after processing where this will be going, where we have to store this. So always think of these things whenever you are doing any kind of programming, that what is the source of this information and where it will be destined after doing the processing. उसको आया कहाँ से और जाना कहाँ है, and they both are related with only one thing: source address and destination address. So in programming or in computing system, everything starts from the address. ठीक है, एड्रेस कहाँ पे फ्लो करेंगे? Where these addresses will flow? Addresses will flow on the address bus. Fine, the bus which deals with the flow of addresses, which is responsible for generating the addresses. Agreed? But just imagine that address bus is not ready. Your address bus is not ready. Fine. So just imagine postman को एक बैग मिला पोस्ट ऑफिस से. So this is your today's assignment. आपको ये सारे पोस्टल ऑर्डर और जो भी पोस्ट कार्ड्स हैं वो डिलीवर करने हैं, बट उस बैग के ऊपर एक लॉक लगा हुआ है. ठीक है, एंड दैट लॉक हैज अ पासवर्ड, डिजिटल लॉक है. जस्ट इमेजिन इट इज हैविंग अ पासवर्ड व्हिच विल एक्टिवेट दिस एंड द बॉक्स विल ओपन और द बैग विल ओपन. फाइन. तो जब तक वो लॉक नहीं खुलेगा वो एड्रेसेस नहीं पढ़ पाएगा. ठीक है, और जब तक एड्रेसेस नहीं पढ़ा जाएगा तो वो डिलीवरी का रूट कैसे सेट करेगा, अपना प्रोसेस शुरू कैसे करेगा. जस्ट थिंक इन द सेम वे. फाइन. तो एड्रेस बस इज रिस्पॉन्सिबल फॉर ऑल द एड्रेसेस. एड्रेस बस वो सब एड्रेसेस को जनरेट करने के लिए रिस्पॉन्सिबल है, बट एड्रेस बस अभी तक एक्टिवेट नहीं हुआ है. Fine. So what is that most important thing? Now just imagine what is that most important thing which will be activating the address bus. What could be that most important thing? That most important thing is your ALE, address latch enable. It activates, it provides the password so that the bag of the postman will be opening and it can read the addresses. Technically, what it will be doing, it will be activating the address bus so that address bus can be able, address bus is able to generate all the addresses, and the process can communicate by the phenomena of source and destination. They both needs an address. Fine. So this way you can understand that ALE is the most important. Just imagine like a switch, that ALE is a switch. Fine. Until and unless the switch is off, nothing will happen. Literally nothing will happen, because once we do not know about the address, आप काम ही शुरू कैसे करोगे? आपको यही नहीं पता कि पहला डेटा कहाँ है, प्रोग्राम कहाँ से शुरू करना है, लोडिंग कहाँ से करनी है, सोर्स कहाँ है, डेस्टिनेशन कहाँ है, एवरीथिंग रन्स अराउंड द एड्रेसेस. Fine. So once this is off, you will not be able to access anything in the memory or inside the microprocessor. Fine. So it's just a switch which turns itself on to activate all the process. ALE का अगर स्विच ऑन नहीं होगा तो प्रोसेस में कुछ भी स्टार्ट नहीं होगा. अंडरस्टूड?
Yes, sir.
Alright. The same operation is for BHE. BHE does the same operation when it is connected with the maximum mode. All right. So now come to the maximum mode signals. So in the maximum mode, the first set of signals are RQ and GT. Fine. RQ stands for request and GT stands for grant, transfer or grant, transmit. It could be anything. Fine. So this basically deals with the transfer of data and reception of data by two pins. First pin and the second pin, RQGT0, RQGT1. So in place of hold and HLDA, RQGT will takes place inside the pin number 30 and 31 when maximum mode is getting selected. Okay. Next is what we have, these three pink color pins. They are called S2, S1, S0. They are the status pins of maximum mode. That provides us the status of maximum mode. That means what is happening inside the maximum mode. What is happening inside the maximum mode? What it is doing right now. So S2, S1, wherever you find an S, they are always related with some status. So this time S0, S1, S0, S0, S1, S2, there is a table something like this 0, 0, 0, 0, 0, 1, 0, 1, 0. So when this particular states is available on this S2, S1, S0, so there is a particular operation which is happening in the maximum mode. I'll show you that table, what is happening inside that. Fine. So this is just for showing the status, what is happening inside. If sometime I ask you, tell me what is happening inside 86. So you can connect your multimeter at these S2, S0, S1 and you can note down what are the status 0, 1, 0, whatever it is, and you can correlate and check from the table that sir this is happening at this point of time. So this is for checking and reading the status of this microprocessor 8086. Fine, next we have is Qs0 and Qs1. Fine. So Q connected with S again. So this is again giving us some status. But this Q, what this Q is, this is actually a Q. Fine. So since the microprocessor is all this 8086 microprocessor, this is having an architecture object inside it which is termed as Q. Fine. So this is to provide us the status of Q, and what status it could be like this. So if I say, if it is 0, 0, it is like I'm forgetting that clear Q. When it is 0, 1, first byte to be loaded. When it is 1, 0, next byte. When it is 1, 1, it is something like next operation or next instruction, something like this. So every 0, 0, 0, 1, every state gives you a boolean table, and every boolean table will correspond, boolean state will correspond to an operation. Fine. So that QS is basically the status of the Q, and Q is there is a place inside the architecture which is called Q. So this provides us the status of that Q, that what is happening inside the. All right. So what next we have is QS1, QS0, test, ready, and reset. Test, ready, and reset. Although they are very simple to understand, test is for calibration, when I want to test that further that microprocessor is IC, is an integrated circuit. Fine. So I want to see whether the thing which I received is calibrated or not. It is calibrated or not. Calibrated means the way it was designed and tested in factory. Fine. So it traveled a lot of places, lot of conditions, lot of temperature variations, thermal variation, atmospheric variations. So there may be change in some things inside. So we always test the equipments. The same thing is with this. The when processor comes to us, we first test it whether this is working perfectly or वो आने जाने में कहीं गड़बड़ तो नहीं हो गया. Fine, because it goes with many certain conditions. Although they are designed to bear almost 2500 tests takes place on a microprocessor before launching in the market, they have to pass all of them. So that makes them almost rigid and versatile. So they can be used in the Alaska, they can be used in the Sri Lanka, they can be used in the Pondicherry, they can be used anywhere in the world because they are actually designed like that. But still, there is a pin inside them which by which we can test whether this thing is working perfectly fine or not. So by test pin, we can calibrate, we can see whether this thing is perfect or not. Fine. Ready and reset are again processor signals. Ready is for checking whether the processor is ready to operate or not. Fine. So this is again an input signal. We provide ready and then we check whether the processor is ready or not. If processor is ready, processor will reply from somewhere in the pins, but if it is not ready, it will not reply by any input output. Fine, so that makes us understand that processor is already occupied somewhere doing something, maybe involved in a task. Fine, so next is your reset. Reset is to reset many things inside. Reset is to reset this microprocessor which is known as 8086. Now I'm having very short time. Tell me something about the reset. What do you guys understand about the reset? Quick.
Coming back to the initial state.
Reset means getting the initial state. All right. Anything else? Anyone? What could be the meaning of reset? Because this is the point where you need to be particularly sure about something. But what will happen when you press reset in the uh, processor kit of 8086? There are few particular things which will happen. Getting to initial state is one part of it. That is fine, no problem. That is not the whole. Anything else anyone wants to add? Because there are many related things with it. Sometimes you might have all correlated with the restart. Fine. So restart and reset, are they same? Reset and restart, are they same? Anyone?
Yes, sir.
Reset and restart, are they same?
Not
Restart.
same.
Rest,
मीनिंग वही होता है कि ये मतलब एक वो नॉर्मल कंडीशन होती है उस तक जाना.
no. Restart is a process of turning power from on to off to on. Fine. And reset is not involved with turning the power on off on. It is not related anyway with power. Restart means it is actually doing something related to the power. Reset is not related with that. Okay, I'll leave it to this point because first I need to tell you about the architecture. Then I'll tell you what happens when you press the reset button on the microprocessor 8086. What actually happens? It will not restart. You will not see there is a restart happening in this. No. Then you will see something else. That processor system is still on, but many things happened. Fine. So We need to take care of those things which happened. Okay, so what we are left with? Anything? Anything? Are we left with anything?
No, sir.
I repeat, look closely. I repeat, are we good with everything? Have we? There's nothing left to discuss. If this is the case, then I have few questions for you regarding or related to this pin diagram. We'll discuss them later. Question number one is: have you ever seen a device with two grounds? Why there are two ground pins in the 8086 microprocessor? Since none of you asked, that's why I'm asking that. Fine. And what is the function of lock? These two things I left intentionally. There are two grounds in 8086 microprocessor, and what is the function of lock? Fine. So be prepared with your answers. This is what I'll be asking you next time as the first thing.